Okay, so this is the fourth or the last video of the Unit 1 motion in or kinematics in one dimension topic of frames of reference, position, displacement, and distance. And I've moved on to this next slide here. So we started talking about how we're going to show position on a frame of reference. So for most problems, at least initially, we'll identify initial and final positions on the X or Y axis. We'll usually designate which is which, the initial or final position, that is, with subscripts. I'll try to be very consistent, but subscripts corresponding to initial and final positions may vary depending on the circumstances of the problem. But these are the designations that we'll usually use. If I'm on the x-axis, okay, if we're on the x-axis, usually for my initial position, I'll show that as x0, my final position as x. But I may show my initial position as x1, my final position is x2. I may show my initial position as x sub I, and my final position is x sub f. On the y-axis, the same thing. If my initial position is usually going to be y0, my final position will be y, and so on. So that's how we're going to use variables for our initial and final position. Okay. Now, we'll discuss how to obtain values for position and motion problems and place them on motion diagrams in a little bit later section. But I actually want to illustrate how we're going to do this right now, just so that you're aware of it as we begin to talk more and more about this. So I want you to write these down on your worksheet. I'm going to go to a screen here where I could draw. And so for this first one, I've said illustrate the placing of an initial position of 2 and a final position of 7 on our frame of reference in the x direction. And so my frame of reference in the x direction is always going to be something that looks like this, where I've got an origin at 0, and I'm going to show the positive x direction like this, plus x. And if I want to put a beginning position of 2 on my diagram, that's all I'm going to do. I'm going to say x0 equals 2. If I want to, I can put a little mark there to indicate that that's where 2 is. And then I'm going to say my final position, x, is 7. Okay, so that's all I would do to show the position, the initial position of 2 and the final position of 7. If I wanted to do this on the y-axis, okay, and if I'm going to need some negative numbers, I will move my origin a little further along the line there and say, here's my 0 position, here's my positive y values, the direction of positive y values, and I'm going to say, and we're going to use y here instead of x. Oops, bigger size. So y0 equals 0, and then y equals negative 4. So that's how we're going to designate this, my initial position and my final position. Okay, so simple as that. And this is going to be how we start to describe motion. So we'll go back to the Nearpod here. And then we're going to talk about a couple of concepts here as far as change of position goes. So hopefully it makes sense that if I can put an initial position and a final position on my frame of reference. I can say, here's my initial position and here's my final position. The next step in this is saying, well, how much difference is there between my initial position and final position? Okay, I went from my initial position to my final position. How much difference is there between that? I would need to say that. I would need to find out what the change in position is. And that change in position is simply going to be the value of the final position minus the initial position. Okay, and that's what this means here. Delta means change of, so the little triangle symbol is a Greek delta letter, the Greek letter delta, and that means change of. So change of position in the x direction means my final x position minus my initial x position. And this change of, in order for the math to work out, it's always going to be that it's final minus initial, final minus initial. Okay, so x final minus x initial. Or if I'm in the y-axis, y final minus y initial. Okay, so we want to make sure that we can state this in words, that we can turn our math statements into words. So I'm going to come over here in my notes and type this out for you. What I want you to say here is, this phrase, this mathematical formula states change in, or change of position is equal to the difference in the final position and the initial position. Okay, change of position is equal to the difference in the final position and the initial position. So the difference, meaning the negative sign or the subtraction, that's what a difference is, right? It's a subtraction. So the difference in the final position and the initial position. Okay, so that's how we're going to state that. So let me show you an example. We're going to go to so we'll go back to our drawing screen. And let's just use the example we already have. So here's my frame of reference, my origin, and the direction of positive x values. And we said x0 equals 2 and x equals 7. So my final position and my initial position. And the other thing that I want you to get used to at this point is that we're going to also start writing these things down in a list. So I'm going to have the word given here. What information have I been given? I've been given that x0 equals 2 and x equals 7. So that's the information that I've been given. Okay, now we want to create a formula that's going to show me what the displacement is, or the change in position. So remember again that delta x means change of position in the x direction. So change of position. And you don't need the little lines there. Change of position equals final position x minus initial position. And we're also going to need to get into the habit. You're going to have to write out the actual formula before you put the numbers in. Now, you can all see just by looking at this that the change of position is 5 units, right? But you've got to demonstrate that to me by writing it out. So delta x equals x minus x0, and this equals 7 minus 2, and that's going to equal 5. Okay, so my change of position in the x direction was 5 units. I went from 2 to 5. I increased the distance from the origin by 5 units. Now, you'll notice that the next question on the Nearpod says, what happens if you make it so that the initial value is greater than the final value? Let's do that. Let's say now that our x0 is 7 and our final position is 2. Let's see how that changes things. So delta x, or my change of position, right? My change of position equals final position minus initial position, right? X minus x0. So now my final position is 2 and my initial position is 7. So now that's going to equal -5. Now, I'm not at a value of -5, am I? What has happened is that I've gone 5 units in the negative direction. Okay, I've gone 5 units in the negative direction here. I've gone from 7 to 2. And so what we need to always make certain is that our math, the formulas that we use, the values that we get are corresponding to what we see on the diagram. On the diagram, I'm going from a position of 7 to 2, so I've gone -5 units. Okay, it's not a value of -5, it's a value of 5 in the negative direction. So let's make sure we always understand that. Okay, so let's go back to the Nearpod and talk about one last concept here, and hopefully finish out the video here before it ends. Displacement is distinguished from distance, and distance is the length traveled in getting from the initial position to the final position. So what I'm going to say here is that if my initial position was 2, oops, let me go back to the paint screen here and change this to a blank one. So let's say that my initial position is 2 and my final position is 7. We've already said that the displacement here is +5. We've said delta x equals x minus x0 equals 7 minus 2 equals 5. I've gone 5 units in the positive direction. But that may not be the same thing as the distance that I traveled to get there. And here's what I mean by that. Maybe to get to 7, a position of 7, I did this. And so maybe the distance that I traveled is 117 units. Okay? I only ended up 5 units from where I started, and that's what displacement is. What is the difference between where I ended up and where I started from? But distance is the path that I used to get there, right? Distance is going to be the path that I used to get there. So we need to make sure we understand the difference between distance and displacement. And the other real difference in this is that it doesn't matter which direction I went. I could have gone from here to here. I could have gone from 7 to 2. The distance that I went was still 117 units. So when I talk about distance, I don't use direction. Okay, I don't use direction when I talk about distance. I just say I went 117 units. Now, when I go from 7 to 2, my displacement would be -5, right? If I went from 7 to 2, my displacement would be -5. And let's just show that. Delta x equals x minus x0. And then it would be 2 minus 7 equals -5. Either way I go along the path, I've gone the same number of units, 117 units, but the displacement would be different if I went in a different direction. The number of units would be the same regardless of which direction I went. So I'm going to need to stop this video. Actually, we're going to end up having one final video. Go to that. Now, you'll notice that the next question in the